Find the initial velocity. It means u we need to find of a car which is stopped. Now because it is stopped, we say the final velocity v equal to 0 in 10 seconds, time equal to 10 seconds. By applying brakes, the retardation due to the brakes is 2.5 meter square. So here the acceleration is retardation, so we have to put minus 2.5 meter per second square. So let's write the information. The initial velocity we need to find. So now here we see that the initial velocity u, this we need to find, that is our question. The final velocity is given as 0 because the object stops. So v equal to 0 meter per second. The time is given as 10 seconds, so that is t equal to 10 seconds. And the acceleration, they said, is minus. Why have we put the minus sign? Because it is retardation. Remember, this object is slowing down, it is stopping, so it is negative acceleration, which is retardation. We have three equations of motion. V equal to u plus at. We have s equal to ut plus half at square, and we have v square equal to u square plus 2as. Now which one do we use? We're going to use this first one because we need to find the initial velocity. So we have v equal to u plus at, and let's put in our values. The v we saw was 0, yeah. The u we need to find. The a was given here as minus 2.5, and the time was given as 10 seconds. So if 0 equal to u, this minus 2.5 into 10 is minus 2.5. So u will be plus 2.5 meter per second. So initial velocity equal to 2.5 meter per second. If we examine the sum, what is happening in the sum? The body is first moving with a velocity 2.5 meter per second, and then it is stopping. Stopping means final velocity is becoming 0. Here it will be retardation. There is a decrease in velocity, and because there is a decrease in velocity, the acceleration is negative, and it is called retardation. A train starting from a stationary position and moving with uniform acceleration attains a speed of 36 km per hour in 10 minutes. Find its acceleration. A train starting from a stationary position means u equal to 0. So we put here u 0 meter per second. Moving with an uniform acceleration attains a speed of 36 km per hour. That means v is equal to 36 km per hour, the final velocity. So that is 36 km per hour in 10 minutes. So time, this is time, is 10 minutes. So this is 10 minutes. Find its acceleration. The acceleration we need to find. So the A is our question. So the first thing we have seen, to see everything is in the same unit. And if you look up here, this is 36 km per hour. It should be meter per second. Now to change kilometer per hour into meter per second, that's a rule. We got to multiply it by 5 by 18. And when you multiply 5 by 18, it becomes meter per second. And when you reduce it to, so this is now 10 meter per second. So our V is 10 meter per second. Here also our time is given in minutes. We can't work in minutes, we need to work in seconds. So when we convert, will be 10 into 60. So that would be 600 seconds. Now our three equations we know as V equal to U plus AT. Then we have S equal to UT plus half AT square. and we have v square equal to u square plus 2as. We are going to use the first one. So we have v equal to u plus at, and I put in the values. The v is 10, the u is 0 because it is starting from rest. We saw the a we need to find out, and the t was given as 600. So 10 equal to 0 plus 600a. So 10 equal to 600a, and a equal to 10 over 600. So we have a equal to 1 by 60, and the unit of acceleration is meter per second square. So this is a on dividing, you get 0.016 meter per second square. A bus was moving with a speed of 54 km per hour. On applying brakes, it stopped in 8 seconds. Calculate the acceleration. Now, a bus was moving with the speed of 54 km per hour. That means the u equal to 0. It had an initial speed of 54 km per hour. So let us put it down, u equal to 54 km per hour. Now this is not SI unit, but let us change it later. On applying brakes, it stopped. It stopped means final velocity is 0. So final velocity v equal to 0 meter per second. In 8 seconds. 8 seconds means time is 8. So we'll put time, that is t equal to 8 seconds. Calculate the acceleration. So the acceleration we need to calculate. Here, check if all your quantities are in the SI unit. The SI unit for speed is meter per second. And if you notice here, the initial velocity u is not in SI unit, it is kilometer per hour. So we need to change to meter per second. To change to meter per second, we have to multiply by 5 by 18. And on multiplying this, we cancel this. This is 9 2s are 9, say 6, 1s are 3s are. So this becomes now 15 meter per second. Now again the three equations of motions. Here again we use the first equation because we know v, we know u, we know t, and we need to find a. So starting from the first equation, v equal to u plus at. Let's put our values. Our initial final velocity is 0. The initial velocity we see was 15. U was 15. The a we need to find out, and the t was given as 8. So 0 equal to 15 plus 8a. Take the 15 on the other side. Minus 15 equal to 8a. So a equal to minus 15 over 8. So a equal to minus 15 over 8. Unit of acceleration meter per second square. When you divide this, your a will be minus 1.875 meter per second square. Now just to understand this, why did we get this negative acceleration? We got this negative acceleration because this body was slowing down. From 15 meter per second, the body stopped. Stopped means the velocity became 0 meter per second. So when a body slows down, the acceleration is negative, and it is called retardation. A body starting from rest travels with a uniform acceleration. If it travels 100 meters in 5 seconds, what is the value of the acceleration? A body starting from rest. If it is starting from rest, means u equal to 0. So the initial velocity u is equal to 0 meter per second. Travels with uniform acceleration. If it travels 100 meters, that means the distance s is 100 meters. So let's write here, we have distance, we call it s, and that is 100 meter. In 5 seconds, so time equal to 5 seconds. So time t equal to 5 seconds. Calculate the value of its acceleration. So acceleration is question. So we need to find its acceleration A, which is a question. Now these are our three equations of motion. Let us see which we are going to use. To select this, first we must know what is given to us. Look at the first equation. Do we know the V? No, we don't. Do we know U? Yes, we know. Do we know acceleration? No, we don't. There are two unknowns. If there are two unknowns, you cannot handle this equation. So this, we cannot use this one. So this, we erase it. We don't use this. Let us check on the second one. Do we know distance? Yes, we know distance. Do we know initial velocity? Yes. Do we know time? Yes. Do we know acceleration? No, we don't know acceleration. We need to find acceleration. Do we know time? Yes. So in this, only one unknown, and which is the unknown? The acceleration is unknown. So we can start using this equation. S equal to ut plus half at square. So we go ahead and use, we know our distance, S is the distance, which is 100. So we will put 100. U, initial velocity 0. The time is 5 plus half. Acceleration we do not know, and we know the time was 5, so this is 5 square. We go ahead and solve it. 100 equal to 0 into 5 is 0 plus half into A, and 5 square is 25. So 100 equal to 25A over 2. 100 into 2 over 25, I'm cross multiplying, equal to A. And when you cancel this out, you get 8. So acceleration is 8, and the unit for acceleration is meter per second square. So that's your answer. A bus increases its speed from 36 km per hour to 72 km per hour in 10 seconds. Find its acceleration. A bus increases its speed from 36 km per hour. So the initial speed is 36. So let's put that. U equal to 36 km per hour to 72 km per hour. So final velocity is 72. So that is 72, which is our V, is 72 km per hour, and here they said in 10 seconds. So time equal to 10. So 10 seconds. Now there's one thing we know is here it is in kilometer per hour, and we need to change it to meter per second. So to do that, we need to multiply. So we equal to 36 to make meter per second. We need to multiply it 5 by 18, and when you reduce it, you will get the answer 10 meter per second. This is the SI unit. The same procedure we do for the next 72 km per hour. To change meter per second, you do 72 into 5 by 18, and this will work out as 20 meter per second. Here to find acceleration, we'll straight get on. We know acceleration equal to V minus U over T. So acceleration equal to V is 20, that's a final velocity. U is initial velocity, that is 10, over time is 10 seconds. So acceleration is 10 over 10, and acceleration is 1. Unit of acceleration, meter per second square. There's one thing I want to bring to your notice is, see, this equation is the same as A equal to V minus U over T. When you cross multiply, what happens? The T goes on the other side, you get AT equal to V minus U, which means V equal to U plus AT. It's the same as the first equation of motion. A car acquires a velocity of 72 km per hour in 10 seconds, starting from rest. Find the acceleration and the distance traveled in this time. A car acquires a speed of 72 km per hour. That means the final velocity is 72 km per hour. So let's put that. that is final velocity v, is 72 kilometer per hour in 10 seconds. So time equal to 10 seconds. So here we have our time, that is t equal to 10 seconds. Starting from rest, if it is starting from rest, means your u equals 0. So u equals 0 meter per second. We need to find acceleration. So this acceleration is a question, and distance traveled. So the s we need to find, distance traveled. So the first thing you've seen that the final velocity is not in the proper unit. It is kilometer per hour, and we need to change it to 2 meter per second, for which we have to multiply 5 by 18. And on this, doing this calculation, your answer will become 20 meter per second. So a v we are going to take as 20 meter per second. So we start with the first equation, v equal to u plus at. The final velocity is 20, so we'll put 20. Your u is 0 because it is starting from rest. The a, we need to find the acceleration, and the time is given as 10 seconds. So 20 equal to 10a, and a equal to 20 over 10. So a equal to 2 meter per second square. So let's put this here, 2 meter per second square. Now we need to find also the distance. To find distance, we use the formula s equal to ut plus half at square. S we need to find. We know the u is 0, our time is 10, half. The acceleration we have just found is 2. Our time is, we said, is 10 square. So s equal to 0 into 10 is 0, plus this will cancel out. So you will have 10 square, which is 100. So the distance is 100 meter. A motorcycle moving with a speed of 5 meter per second is subjected to an acceleration of 0.2 meter per second square. Calculate the speed of the motorcycle after 10 seconds and the distance traveled in this time. A car moving with a speed of 5 meter per second. So the u initial velocity is 5 meter per second. So u equal to 5 meter per second is subjected to an acceleration of 0.2. So acceleration is 0.2. So let's put that in, acceleration 0.2 meter per second square. Calculate the speed of the motorcycle after 10 seconds. So time is 10. We have to calculate the v, the final velocity. So v, the final velocity, is a question mark. The time is 10 seconds. And also the distance traveled. So we need to calculate the distance traveled, that is s. We start with the first equation, v equal to u plus at. And we have seen the final velocity we need to know, that is v. The initial velocity is 5. The acceleration is 0.2 and the time is 10. So v equal to 5. 0.2 into 10 is 2. So final velocity is 7 meter per second. So we put here final velocity, we found 7 meter per second. Now we need to also find out our distance. So for that we use the formula s equal to ut plus half at square. The distance we need to find, the u we've seen is 5. The time we see is 10, which is given to us, plus half. The acceleration is given to us as 0.2, and the time again is 10, so this is 10 square. S equal to 5 into 10 is 50 plus half. Now this 0.2, so it means 2 over 10. I remove the decimal. There's one decimal place, so I put 1 0 down, 10. And 10 square is 100. So S equal to 50. Here I will reduce 2 will cancel, this will cancel. So what remains now here is 50 plus 10. So the distance is 60 meter. A bus running at a speed of 18 km per hour is stopped in 2.5 seconds by applying brakes. Calculate the retardation produced. A bus running at a speed of 18 km per hour. So it has an initial velocity of 18. So u equal to 18 km per hour is stopped in 2.5 seconds. So the time is 2.5 seconds. Time t equal to 2.5 seconds. By applying brakes, it has stopped. If it has stopped, that means the v must be 0. The final velocity is 0 meter per second. We need to find the retardation. Though this retardation we need to find. Here one unit is not in the proper SI, one quantity is not in the SI unit, that is kilometer per hour. We need to make meter per second. So we do 18 into 5 by 18, and that would be now 5 meter per second. So the initial velocity is 5 meter per second. So we use the equation of motion, which is v equal to u plus at. So the v we saw is 0 because the body stops. The initial velocity is 5 meter per second. The acceleration we need to find. The time is 2.5 seconds. So we have 0 equal to 5. A into 2.5 is 2.5a. So the 5 goes on the other side, becomes minus 5, 2.5a. And the a is minus 5 over 2.5. So a will be equal to, now to remove this decimal, we move 5, we put 10 on the top here, was one decimal place, over 25. And when you reduce this, you get your a as minus 50 over 25, and a is minus 2 meter per second square. So your retardation you will write as retardation is 2 meter per second square. You will not put a minus because retardation is given. But if you were to say what is the acceleration, then acceleration is minus 2 meter per second square. Because they've used the word retardation, you already know the negative sign should be there. So just say retardation 2 meter per second square. But acceleration will be minus 2 meter per second square. Again, why did the acceleration come negative? Because first the velocity was 5 meter per second, now it has become 0. There was a reduction in velocity, and when the velocity becomes less, decreases, acceleration is negative. A train starting from rest moves with a uniform acceleration of 0.2 meter per second square for 5 minutes. Calculate the speed acquired and the distance traveled in this time. A train starting from rest, so initial velocity is 0. So here write u equal to 0 meter per second. Moves with an uniform acceleration of 0.2. So acceleration is 0.2. So we put acceleration a 0.2 meter per second square for 5 minutes. So time is 5 minutes. So time equal to 5 minutes. Calculate the speed acquired, means we have to find the final speed v, and the distance traveled s. Let us check if all our quantities are in the SI unit. We find the minutes are not in the, time is not in the SI unit, so you do 5. Here I'll multiply by 60 to make it into the SI unit. So 5 into 60 is 300 seconds. So the first thing I do is start using my equation, and I will use the equation v equal to u plus at, and put my values. So the V I see we need to calculate. U is 0. The A is given as 0.2 and the time is given as 300. Now to further the calculations, 0 we ignore. So this is, we have to calculate this. So 0.2 is 2 over 10. 2 over 10 into 300. This cancels out. So V equal to 2 into 30, 60 meter per second. So we found out the final 60 meter per second. Now we need to find the distance. To find the distance, we will use another formula, and that is S equal to ut plus half at square. And put your values out there. So we have S, we know our U is 0, and the time was 300 plus half. A was 0.2 and T was 300. So this is 300 square. So S equal to 0 into 300 is 0 plus half 0.2. 0.2 is 0 over 10. And that is 300 square. So that is 300 into 300. So I cancel this out. This 0 here. So S becomes now 300 into 30. S is 9,000 meters. And 9,000 meters is 9 kilometers. You may not convert into kilometers. You may keep it as it is. A bus moving along a straight line at 20 meter per second undergoes an acceleration of 4 meter per second square. Find its speed after 2 seconds. So a bus moving along a straight line at a speed 20 meter per second. So this is the bus initial velocity 20. So we'll put here U equal to 20 meter per second. Undergoes an acceleration of 4 meter per second square. So acceleration 4 meter. So we put acceleration here 4 meter per second square. Find the speed after 2 seconds. So time is 2. So we put time as 2. Time is T, which is 2 seconds. We need to find the final velocity. Find its speed. So the final velocity V we need to find. And an easy sum. This is my question mark here. So this is quite simple. We just go ahead and start doing it. We do V equal to U plus 80. And the V we need to find. The U is 20. The A is given as 4. The time is given as 2. So V equal to 20 plus 8. So V equal to 28 meter per second. So the final velocity is 28 meter per second. In this case, the U is not 0. However, the U is 54 kilometer per hour.